So as you know, the topic has two types of concepts, permutations and combinations. So we already discussed permutations. And now we will move on to combinations. The only difference is in permutations, when we were discussing words and the number of ways they can be arranged, the thing was that we were considering order in that case. In this case, order doesn't matter. In permutation, order matters. So that's the only difference. I'll explain this through examples so this becomes a little bit easier. So moving on to let's see the type of questions we have in this case. So these are all combination based questions, meaning that I give you an example. Let's say a cricket squad is selected. So out of, let's say, a pool of 20 players or 23 players, only 11 IPL players or the country Indian national players are selected. So those are combination type questions. That means that the order doesn't matter in that case, like in permutations. So let's say I'll give you a small example initially. So let's say there are 3 people, ABC. So because the example of cricket is too large, out of 20 players, you are selecting 11 players. I cannot manually write all those possible combinations here. But let's start with a small test case, which only has 3 players at a time. So these have 3 players, ABC. I'll name them ABC. Now let's say I want to select out of those only 2 players. So one will be disqualified, only 2 will be selected in the team. So how many types of combinations will be there? There will be 3 of them, AB, BC and CA. Now these are the only possible combinations that you can select. Now if you remember from permutations, it mattered that in a word, when let's say we were discussing a word smart in our first lecture. Now it mattered that, you know, in the word smart, that SMART, if I swap the letters of the word, S comes first or M comes first, it mattered. So let's say in that case, in permutations, AB is the word. Now we used to write it as BA as well, because 2 factorial, right? So there are 2 possible ways. But in this case, it doesn't matter if I write AB or as BA, because it's the same 2 people. So in this case, in combinations, it doesn't matter if I select, let's say there are 2 players, Virat Kohli, and let's say the other one is Rohit Sharma. It doesn't matter in which order they come. Those 2 have been selected. So it doesn't matter if you put Kohli first or Rohit Sharma first. It's the same thing. In this case as well, player A and B have already been selected. You cannot write them BA as, you cannot say that BA is a different combination. So only 3 are selected, AB, BC, CA. So all are just considered once. So we can also conclude from this that the number of permutations are always greater than number of combinations, because in permutations order matters. So the number of arrangements are much more than in combinations. So let's come to the question. So it's a similar concept. You are choosing the number of people out of some pool. So in this case, out of 5 men and 3 women, so let me just write 5 men and 3 women. I'll denote them as this, like this. A committee of 3 members is to be formed so that it has 1 woman and 2 men. So what you're saying is that I need to form a committee of 3 members, out of which the condition is 1 has to be woman and there will be 2 men. Now in total we have 5 men and 3 women. So how we will do that? So basically I'll shift this to the side that you need 5 men and 3 women. And your committee has to be 3 members. So how we write this as, out of 5 men, we denote combination as this, 5C, out of 5 men, you're selecting only 2 men. Times, what about women? There are 3 women and only 1 is to be selected. So this becomes your equation. So C just means combination. So the first number that comes is your total pool. So you have total 5 men and out of that you're selecting 2 men. So out of 5 you're selecting 2. So 5C2. So 5 select 2 is how we read these. Read this equation or this notation. And for women, we have 3 select 1. So 3C1 or 3 select 1. So the actual formula for combination is this. So similar to permutation, your entire total pool, 5 factorial, comes at the top. And in permutations, if you remember that we only selected the number that comes later, as 2 factorial. But in this case, we will consider 2 factorial as well as 3 factorial, which is 5 minus 2. So the equation is a little bit more complex, but the idea is the same like I explained. And in this case, this will be 3 factorial divided by 2 factorial and 1 factorial. So this becomes your equation. And if you can solve this, this becomes 5 factorial is 120 divided by 2 factorial, which is 2 times 3 factorial, which is 12. 2 times 6 is 12 times 3 factorial, which is 6 divided by 2. This becomes 3 and this becomes 10. So there are 30 different possible combinations or ways that this can be done. So the reason, again, we are multiplying this because you always multiply in the case when you're forming a committee. Now, if you change this in the next questions, if you see, there will be other conditions. So we'll be adding it as well later. So we'll see what's the difference when to add and when to multiply. So moving on to the next question. Now, in this case, there is a different condition that at least one member is a woman. So in this case, we'll be adding stuff as well. So out of what's our pool again, a committee of 3 members is to be formed. And you have 5 women and 4 men. And the condition is at least one of those members should be a woman. So this means that, at least one member is a woman. So this means there will be greater than one woman. So there could be 1, 2, or 3, up to 3, because the committee is again 3 members total. So you can have all 3 women, 2 of them could be women and 1 man, and then only 1 could be a woman, and the other 2 will be men. So let's see how to solve this. So first of all, we'll take, there'll be just let's say all 3 of them are women. So out of 5 women, you select 3. So that's it. This is one possible way you can do this. Now we'll be adding. So the thing is that you must have been exposed to topics like could be probability, or maybe like Venn diagrams, or maybe something related to probability. You know that we add when we have independent events. The reason we are adding here that these are independent events. They cannot happen, they cannot coexist at the same time. If you selected 3 women, can you select also 2 women at a time? That cannot happen. It's done. So if you select 3 players, it's done. That's it. That's your sequence. So that's why we add. Now, if we have 2 women, that's a different sequence. So that's why we add that. So now I selected 2 women, you can see, out of those 5. So 5 select 2, and then I multiply that with the men, because that comes under the same sequence. That's the same event. So within an event, you multiply, and 2 different events you add. Right? So what about men then? So now you have 1 man. So out of 4 men, the reason I put 4 is because in the total pool we have 4 men. So 4 select 1. Now moving on to the third event. Now third event again would be independent of the second and also first. So in this case, what we do is we are selecting only 1 woman. Because like I said, we have taken 3 women and then 2, and now we will take obviously 1, because now you only have option of 1. So multiply by, so this I'll rewrite this again. So now you can basically see it in a better way. 5 C1, 5 select 1, and then obviously 2 men are remaining. So out of 4, 2 men are remaining. So now the tricky part comes that the calculations are more involved, but you have to manually calculate this. So this becomes again 5 factorial divided by 3 factorial, 2 factorial. So that is 120 divided by, again, you can just calculate it quickly. This is 6 times 2, 120 divided by 12 is 10. Now add this to the second event and third event. So let's calculate this. 5C2 is basically just again 5 factorial divided by 3 factorial times 2 factorial, which we just did. It's the same thing. So this again comes out to be 10. So you can do this a little bit faster if you see that, 5 select 3 and 5 select 2 is the same thing, because in the denominator it becomes the same thing. So it's the same value. Times, this is just 4, because again, you will do 4 factorial divided by 3 factorial times 1 factorial. So which is 24 divided by 6, which is 4. So another shortcut, mental shortcut you can use is that always when you have something like this, 4 select 1 or any number n select 1, basically if I write it here, n could be any number, this is always equal to n. Because again, you only have one combination. You're only selecting one at a time. That's it. So this makes it a little bit easier. And then in this case, it's again 5 because you have 5 select 1. 5 times, again, this is 4 factorial divided by 2 factorial times 2 factorial. This becomes 24 divided by 2 times 2, which is 4. So this becomes 6. So this becomes 30, I guess, and this is 40, and this is 10. When you add them all up, this becomes 80. So that's your answer. So the logic here is in building the equation, not the calculations. So that's the logic. Once you're done with making up the equation, you're set. You're good to go. So coming to the next question. I'll make this a little bit faster because question is a little bit more involved. So trying to save time. So this says a committee of 5 members is to be formed out of 3 trainees. So this is your total pool. Like you had men and women. Women in the first 2 examples. Now you have job roles of people. Let's say these are job posts. There are 3 trainees, 4 professors, and 6 research associates. That's your total pool. So let me write that down here. 3 trainees, 4 professors, and 6 research associates. And out of that, the committee should have. So this is a little bit more involved because now you have 2 cases. One time you have 4 professors and 1 research associate out of 5 members. And then you have 3 trainees and 2 professors. Meaning in first case, you don't have any trainee. In second case, you don't have any research associate. So the thing about this is confusing is that you might think that out of 5 members, there is this kind of pool, and then it's putting another condition. So you see there are 2 layers to this. So what you can do this, the way we do this is that we ignore the first term, 5 members. Because we are not considering the committee as a whole first. Because it's saying that out of this pool, I'm selecting 4 professors and 1 research associate. Right? So how I'll do that is because your total pool has 4 professors. So this becomes, so I'll write down the first case in the bracket. So this becomes, I'm using a square bracket instead of just normal because the equation becomes a little bit longer. So this becomes times, this means 4 out of 4 professors, I'm choosing 4 professors like it says. And only 1 research associate is selected out of 6 research associates, which is just 6, select 1. And now I add this to the second case. So this is your first case, and this is your second case. In second case, it says you have 3 trainees and 2 professors. So that means out of, again, 3 trainees, which is your total pool, you are selecting all 3 trainees. So that is again, 3 select 3 times, you're selecting 2 professors out of how many? 4 professors. So this will be 4 select 2. So this equation is a little bit much easier than previous question or example that we solved, because you can see that this is just 6, and you should be quick with this now. And this becomes, again, this is just 4 factorial divided by 4 factorial, this becomes 1. So this first case, you have a total pool or total combinations that come out is 6 plus, this should also be 6. If you can see, this is just 1, this is 6. How is this 6? We can just calculate 4 factorial divided by 2 factorial, because it's 4 select 2, so 2 factorial times 2 factorial, this becomes 24 divided by 4, which is 6. So again, for second case, it's also 6. So in total, you have 12 combinations. For A is the answer. 12 combinations is the total number of combinations across both cases if we add them up. Now again, I totally explained in the best and easiest possible way that I can that why we add is because those are independent events. If I select Virat Kohli and Rohit Sharma, and maybe only those 2 players are selected or let's say this is not a game, not all 11 players are selected, those two are selected to be captain and vice captain. Can I also select in the same case, if I'm only selecting two players, can I also say that, okay, Virat Kohli is the captain and Rohit Sharma is vice captain? And simultaneously, I can also select, maybe in the same game, I can also say that, okay, Hardik Pandya is also the captain. That cannot happen, because you are comparing two different events. Maybe Hardik Pandya can be a captain in a different series or in a different game. So the same thing is there. Once you selected four professors and one research associate, your pool of five members is done for once. So that's why we add. Moving on to the next question. Now, last question is pretty similar to example 2, when we had at least one woman. So in this case also we have at least one woman, but the numbers have changed. So you have a committee of four members. A pool of four members. We need four people, we have to select a group of four people from 8 men and 6 women. So I'll write that at the side. So I remember 8 men and 6 women. Those are the choice we are given, total number of choices or pool. So we have to select at least one woman. So we'll follow similar idea to the second question or the second example. That will be, I can select at least one woman and the total is 4. So how much can I select in total? I will be selecting one woman first, and then 2, and then 3, and then 4. So that's why this question is a little bit long. There will be 4 different cases. So case 1 will be one woman. Case 2 will be 2. Case 3 will be 3 women. And case 4 will be 4 women. And you add all these up, their calculations, and then you get the answer. That's why you can see the answer is a little bit larger, because this question is more mathematically involved. So let's jump into the calculations. So let's say initially I have just one woman. So that will be just 4 select 1, because I only have one option. And obviously there will be men as well. I forgot about the men. So one woman, 4 select 1. And there will be 3 men. So again, sorry, we have to be little bit more careful here. I need to select not out of 4. 4 is the total pool. Out of 6, because I said initially here. That's why you need to remember this. You are selecting one woman or 2 or 3 at a time. So let's say for the first case, 1 at a time. Out of 6 women, 4 is your total pool. Your total members need to be 4. So you cannot confuse 4 and 6, these two numbers in any case. So 6, select 1, and then multiply that by how many men? The pool of men is 8. So 8 select 3. This should be clear to you. The adding part is easy, because those all 4 are again independent events, like I explained the Kohli example, the cricket example. So in this case, this is our first case. And obviously these two numbers, 1 and 3, should add up to 4, because you cannot have more than 4 members in this committee or whatever group they are making. And let's say the second case has now 2 women. So out of 6, we select 2, and obviously out of 8, there will be 2 men. And then you add this, I'm bringing this here. Third case and fourth case. Third case, again, now you have 3 women and only 1 man. And the fourth case, you'll only have, all will be women again. So because it says at least 1 woman. In the last case, like I said, all 4 will be women. 6 select 4, there will be no men. So in this case, there are no men. So this is easier to solve this. This is 6 factorial divided by 4 factorial, 2 factorial. This comes out to be 15. If you calculate this. And like I said, you can first initially solve the terms that are easier. This becomes 8, like we have been discussing. This is 6. 6 select 1, 8 select 1, 6 and 8. And you need to, these are a little bit more involved, but you can indirectly say that this is equal to this, because like I said, the factorial swap, but the calculation is the same. So this is again 15. And we just need to calculate now these 3 terms that are a little bit harder. So 8 select 2 would be 8 factorial divided by 6 factorial times 2 factorial. Now 8 factorial is little bit harder. So if you remember that it comes around to be 40,000. So I'll calculate it exactly, but you can do it through common sense or through having basic number sense. So, but I'll do it for you in the exact way. So 8 factorial is exactly 40,320. 6 factorial is 720 times 2. So this comes out to be 56. So this term is 28. So 15 times 28, we'll solve this later. So let's come back to this first. This looks easier. So this will be 6 factorial divided by 3 factorial and 3 factorial. I'll write this in a better way. So this is right here, 6 factorial and 3 factorial. So this comes out to be 720 divided by 6 into 6, 36. So this comes out to be 20. So 20 times 8 is 160. So third and fourth case are solved. Fourth is 15. Third comes out to be 160 in total. And now we are left with these, only this term. So 8 factorial, 8 select 3 would be, let's solve it down here, would be 8 factorial divided by 5 factorial times 3 factorial. So this would be, again, 40,320 divided by 5 factorial is 120 times 6. So this comes out to be, I think it comes around to be 72 or something. 4032 divided by 12. So you have to estimate this. You cannot just calculate this, because again, like I used to explain in the initial videos, the initial couple of videos, that calculations go up pretty fast. So they become really hairy and involved very fast. So this comes out to be 336 and 56. So you have to estimate this. I don't expect you to calculate this exactly, but you can estimate this. This comes out to be 56 here. And 56 times 6 is 336. So I'm writing this in the bracket, 336. And you have 15 for this and 160. And 28 times 15, this comes out to be 420. So when you, so yeah, the board looks messy, I know that, but the numbers in the bracket are the calculations. So you add them all up, 336, 420, 160 and 15, you'll get 930. So you should be able to estimate this. So that's it. I mean, the concept itself is really important. What matters is that you should differentiate the cases. You should be able to build this equation. You should know when to add and when to multiply. Once you make this, then it's just about the math, which you can estimate, which you can practice with more and more examples. But the concepts are pretty easy. So that's it with the third lecture, and we'll move on to the next few lectures. Thank you.